Hello, my name is Tosunoglu, and the topic I'll be covering is clean water technology. To start off, according to recent estimates, there are about 769 million people without access to clean water globally. This is an important issue to tackle by world scientists, engineers, and governments, since water is a fundamental necessity for the function of society. Clean water sources like the ones I've listed, groundwater, aquifers, lakes, reservoirs, rivers, and streams, are strained by the growing population. These sources listed are naturally replenished, but not at a pace to counteract the increased rate of demand. Primary sources in the undeveloped third world countries such as wells, they tend to fall to poor treatment and become polluted and can also run dry due to high demand. Now, global sustainability of clean water is important on many levels because it is needed not only for consumption but for agriculture and livestock, energy production, and ecosystems. Now, going into the types of technology that exists to clean water, they come in various forms. There are multiple types of clean water technology that can alleviate the problems of demand. Some of them include filters. One of the most naturally existing filters is sand. Running contaminated water through sand can catch large particles primarily, and small biological organisms tend to adhere to sand. And membrane filtration is another type of filter system to purify water. This involves transporting sand through permeable membranes. The type of membrane, whether micro, ultra, nano, determines the pollutants that can be eliminated from the water. Next type is UV disinfection. This is another type of technology great for eliminating pathogens in water. Next is chemical treatment, like chlorination. This is a widely known method that is capable of killing microorganisms, and it's also used as a post treatment for water that's been filtered through using other methods, and then chlorination helps kill microorganisms that cannot be eliminated using filter systems. Another clean water technology is desalination. Now, this process is a type of technology that is not, it's used to produce potable water from saline water sources. This process is not widely used due to its cost, but has the potential to meet the demands of many, since the oceans hold the majority of the planet's water. Now, the two types of technology that I'll expand on is membrane filtration and solar disinfection. Now, the first type of membrane filtration is reverse osmosis. This process involves forcing the liquid of various contaminations through a semi-permeable membrane using high pressure. Now, the pressure, which is seismosmotic pressure, causes the solvent molecules to pass through the membrane, effectively separating contaminants. This process is considered one of the most thorough methods of purification. That's one of its advantages. It is capable of removing many forms of molecules, ions, bacteria from a contaminated source. It is best known for use in desalination and industry processes, but has also been adapted for portability and use on a smaller scale. Now, there are certain disadvantages to this technology. The first is the rejected contaminated water that is backflow from the membrane. Pretty much systems exist that can recover the backflow of contaminated water that does not traverse the membrane, but these systems are generally for industry use and are not developed to be implemented on a smaller scale. Another disadvantage is that imperfections in membranes can cause contaminations to slip through. So pretty much the more perfect the membrane, the higher most likely the cost of the membrane will be. But there is always a chance of imperfections existing in membranes. Membranes over time, they tend to break down and can fall to growth of microorganisms, because this is a high fouling, pretty much high fouling that occurs in reverse osmosis. So the high fouling will cause decrease in efficiency and purification. And another issue with this process is that this type of technology is very expensive, and for processes as desalination, expensive equipment systems would need it in order to purify the water to potable, recommended type of clean water. Now, the second type of membrane filtration is forward osmosis. This is similar to reverse osmosis, but does not use high pressure as the means of traversing the fluid through the membrane. This process is driven by the osmotic pressure gradient, which causes the water to flow from the low osmotic pressure region to the high osmotic pressure side. As shown in the diagrams, you can see that there's a difference as far as which side the impurities will flow. So pretty much the purification flows due to the high pressure. It flows through the membrane, and backwash occurs. The salt water stays on one side of the membrane, while in the other case, the impurities are traversed through the membrane, and the flow of the backwash is actually the pure water for forward osmosis. Now, this process has many advantages. Some of the advantages include a low fouling. So the impurities of the water do not catch in the membrane as much as it occurs in reverse osmosis. It requires less energy to carry out this process. There's high water recovery. A lot of water, pure water is retained, in comparison to reverse osmosis, where the discharged water contains a lot of what you're actually trying to obtain, and it's actually a lower cost technology. But this technology is not as widely implemented as reverse osmosis, and it is slowly developing into a type of technology that it can be implemented on the large scale and smaller scale. Now, the second type of clean water technology that I'll be discussing is solar disinfection. Now, the method of water purification through solar disinfection can be broken down into three categories. The first is electrolytic process. Solar energy can be used to produce electricity that can in turn be used for whether it's electrolysis or some other form of traversing passing electricity through water to break down chemical structures and remove impurities from water. The second is thermally. Heat collectors can be used to thermally disinfect water, increasing the temperature and killing organisms and breaking down certain bacteria through heat. And the last category is solar ultraviolet radiation. Now, high energy ultraviolet radiation can be used to disinfect water naturally. This method is recognized as an effective method of removing pathogenic contaminations from water. It is formally known as SODIS method by the World Health Organization, and it is an established method, an established form of obtaining pure water. Now, these processes are the same that the advantages to using solar disinfection is that the sun is an abundant driving source, pretty much source of free energy. So any technology that using it as a means to disinfect water can be used in many regions throughout the world. The second benefit to this type of technology is that it can be implemented where there is lack of reliable energy sources or remote rural regions. Now, the disadvantages to this type of method of obtaining clean water is that suspended particles still remain in water. So there are certain types of contaminants and certain ions and molecules that may not be ideal to consume that would remain in water, but generally by World Health Organization, solar disinfection through solar ultraviolet radiation is considered, purification through this method is considered capable of being consumed by the general population. And but post-treatment may be necessary to completely remove certain type of contaminants in polluted water or pure water after it's been disinfected through solar ultraviolet radiation or thermally. So now I will go into the type of solution that I think may be able to aid in and alleviate some of the issues that is faced globally as far as being able to obtain clean water. A proposed conceptual design would combine would be a combined water cleansing system. The first stage would use UV purification, and the second stage would use a membrane filtration. And now, similar to the solar system, and the proposed design would use ultraviolet radiation and heat to be able to purify water. The depiction, the model that I have here shows that water would enter glass tubes. And these glass tubes would contain a certain amount of water and would be placed on reflective aluminum parabolic reactors. Now, these photoreactors would help be able to distribute the light along the glass tube, and this would be able to purify the water and hopefully increase time. Certain methods of probably lining the glass tube with titanium dioxide would probably help increase the rate at which the water is purified in the glass tube. And then, if not shown, the water would then be pumped through the second stage, which would be the membrane filtration stage. Ideally, it would be best for such a process, such a system to use for osmosis, and on the second stage, and the reason why the second stage would be necessary is because of the certain types of contaminants that ultraviolet radiation cannot eliminate. the membrane would not have to necessarily have to be as expensive, right? Ultrafiltration or nanofiltration. It can be something of a lesser type of membrane. So it can be more easily afforded and can be adaptable to different types of groups of people. And this system would pretty much eliminate a lot of contaminations in water, if not all. Going through two stages in UV purification and membrane filtration. And that is the most conceptual design that I believe that would help alleviate a lot of the problems that certain regions have as far as obtaining pure water. This process ideally would be used to purify water from any type of source, whether the water source is desalinated or brackish, salinated or brackish water, or water that is that comes from polluted wells or rivers or streams. That would be the hope, that this design would be able to produce clean water from those type of contaminated sources. And this design can also possibly be implemented on a larger scale and not only on a smaller scale. That is all I have for this presentation.